This is probably the one of the complicated subjects of Weblogic. Not many people understand this. Make sure you get a good hang of this. This is going to be helpful for the rest of your life. All the upcoming technologies depend on JMS, SOA, OSB, everything. So fundamentals, they all remain same everywhere. So let's see. Now we'll see first what is JMS, why you need JMS, and finally we go into how Weblogic does JMS. Now the first thing is what is JMS or why we need such a system called JMS. For example, let's say a database is being used by an application, a Java application or a .NET application or some application using a database. And if the database is down, application will not function. So you have a dependency on the database. Application functionality depends completely on the availability of the database. Now here, the communication between application and the database is a synchronous communication. As they depend, app 1 in this case, the application itself depends on the availability of the application 2. So application 1 sends a message, application 2 responds. In this case, the app 2 is a database. If application 2 is not available, application 1 has a problem. Now this is kind of communication is called synchronous communication. And this is what used to be there. I'll give you a couple of examples now. Take an example of the online banking application that we always say. Let's say you did a fund transfer. When you do a fund transfer, the application that it's using is probably directly connecting to a database. That is synchronous communication. After the fund transfer is done, the application generates a message, alert message that you are supposed to receive in SMS. Let's say here you have something like this. Let me open a notepad. So here, let's say this is a Weblogic application. Then you have a database. Alright. The database has updated everything. Once the update is done, it generated a message. The application generated a message. Now the message has to be delivered to you through an application or in a SMS service provider, because the bank itself does not know anything about how to send an application. So here, this is banking app. The banking app has to generate a message, and the message itself has to be given to a mobile service provider, probably somebody like Airtel if you are in India. So this is the service provider, or Airtel or AT&T if you're sitting in US, right? Or somebody else, the mobile service provider. So here, the banking application tries to connect to Airtel application. Airtel application in turn will send you an SMS, because Airtel knows how to send an SMS. It connects to the tower, alright? Then it basically gives you the message to your mobile phone. Now here, if you see this transaction, the communication between banking application and the database is synchronous. What about the communication between the banking application and Airtel? Is it synchronous or asynchronous? Why is it asynchronous? Where did we say asynchronous? Now before we go into synchronous asynchronous, what is synchronous asynchronous? Synchronous is you send a message, you wait for the response. Means the sender no, not that one. Synchronous is basically, I'll come to that one. Synchronous is you're sending a message, you're waiting for a response. Asynchronous, you send a request, you're not waiting for the response. Means the response need not be immediate. Let's say you make a phone call to your friend, that's synchronous. Means if your friend's mobile is switched off, you cannot complete the phone call. Asynchronous is more like sending an SMS kind of message kind of thing, or the voicemail that you left. The receiver need not be present when you are sending a message. Now in the communication that we are talking here, the banking application tries to communicate with the DB synchronously. The same way, banking application tries to contact Airtel also synchronously, let's say. Let's assume that we have such mechanism. If the banking application tries to contact Airtel synchronously, you may have a problem that Airtel is down because that's a external application. It's outside the bank, and Airtel will not guarantee that their application will be available 24/7. So when the banking application is trying to send an SMS, and if the SMS provider is not available, does that mean the banking application will have to wait till the Airtel application becomes available? Is that so in this case? It can't. That's correct. The banking application cannot wait till the Airtel application becomes available, which means our assumption that this is a synchronous communication is not going to be valid. Means this is not going to be practical. This is not something that we want. We don't want the banking application to be dependent on the Airtel's availability. So what we want to do is we basically want to decouple banking and Airtel. So now instead of directly sending the request or the message from banking app to Airtel, you put a storage in between. A storage holds the message, means the banking application is not directly talking to Airtel anymore. A storage has a message. Now banking application simply gives to the storage. Airtel application picks up from storage, and this storage itself is called a Java messaging system. So what JMS does here is it has decoupled banking application from Airtel application. Now banking application does not know anything about Airtel at all. For a banking application in this architecture, you say banking application does not need to know where the message is going because it's not expecting any response. Now the same way Airtel application need not worry where the messages are coming from. If there is a message, if the message contains a mobile number, send the message to that mobile number. That's it. It's pretty simple for Airtel also. So here if you see, both banking application and Airtel application, they connect to the GMS. It is not like a banking sends to GMS, GMS sends to Airtel. It's not that way. GMS is a passive system, which means it's like a post box at your home. Postman comes in, puts the letter into the post box. Does the post box come to your flat and then deliver your letters? or you go to the post box and pick up the letters? Does the post box come to you? No. A post box is, let's say, take an apartment. We usually see in everywhere in India also. So down at the apartment, you have all the letter boxes, every flat. So postman comes in, puts the letters into that box, let's say. Now the letters are always in the box unless you pick them up. So you go down, when you're going down, you basically pick up those letters. Now the JMS system is exactly like that. It's a passive system. Means the message here in this case was given from the banking application. A JMS simply stores it. And when somebody asks for that message, that will be delivered. So JMS here is a passive system. And the reason why we have JMS is we want to decouple banking from Airtel. Or we want to put asynchronous communication between banking and Airtel. They are not talking to each other directly anymore. Banking does not know anything about Airtel. Airtel does not know anything about banking. The moment you have put JMS. So when the banking application is sending a message, it does not tell who is going to receive the message. The same way, Airtel application, when it comes in, it does not worry about who has sent this message. So such a communication is asynchronous. Sender does not worry about a reply, or the sender is not expecting a response immediately. So that kind of asynchronous communication. And the reason why we want asynchronous communication is you want to reduce the dependency. In technical words, it's called you want to reduce, or you want to decouple the systems. That's what it's called. Alright, so here, the basic reason why a system like JMS is required in the first place or in the IT architectures is when you want two applications not to depend on each other, or when you want to decouple those two systems together from each other. That's the requirement of a JMS. So the first rule of point number one, JMS means asynchronous communication. For synchronous, you don't need JMS. Basically, if banking and Airtel are communicating directly with each other, it's synchronous. You don't need to set up a storage in between. So JMS means asynchronous. You need JMS only when there is asynchronous communication. Alright. So application 2, bank and JMS queue will be synchronous communication. Yes, that will be asynchronous. The queue should be available when the bank is trying to send up a message. That's correct. JMS is the one that is making asynchronous between Airtel and the banking. So the JMS itself has to be available. So the asynchronous communication is between banking and the Airtel. And for the asynchronous communication, we'll use usually JMS. It can be called, some people call it JMS, Java Messaging Services, then some people call it Java Messaging Systems. Either way. As opposed to asynchronous, you obviously have the other type of communication, which is synchronous. Means the receiver has to be present when the sender is sending a message, like application and database. If the database is not available, application cannot function. Or application is sending a request, it is expecting a response immediately, so it will wait for the response. That's synchronous communication. So the entire GMS, the fact that arises out of asynchronous communication. GMS means asynchronous communication. Alright. Now let's see a flow. I'm going to give you an example of how JMS actually works in real time. Let's take the bank that you usually use, any bank. Now when you have a bank, you can walk into a bank and you can deposit money. So let's say ICICI Bank you have. Now ICICI Bank has a lot of branches across the world. Let's say all these are branches, the red boxes. Now you can walk into any of these branches across the world and you can deposit money, any of these branches. Now when you deposit the money, the teller in the bank is going to use an application which takes, you usually fill up a form when you go to your bank. The form will consist of what's your account number, your name, the amount you want to put in. Those three fields, let's say. Now, the teller will take that form, punch in those details into the application. Now, the question, is this application directly updating your details to the database? Let's say this is a database where all the customer information is stored, means your account balance, everything is stored here. So here, this is the account, database where all the accounts are stored. Now the question is, tell me this question, is the teller application that the bank guy is using directly updating it to the database, or it's not? Guys, you're there? Hello? Not going to respond, or I can't see it.
Hello, Anil, we are here.
Yeah. So the question is, the teller application, or the guy who is sitting in the bank, is that application directly updating your details to the database, or it's not? Or it's not possible? Or it's not practical?
No, it will update because we have a synchronous communication between banking applications, right, within bank.
If the database is down, the bank is going to ask you to stay in line. Is that what we're going to do? And you will wait across the world?
No, probably not.
Yeah, you won't. You will go to the next bank. So here, the application that they are using, or the teller is using, if it is directly updating a database, probably that's not practical. Anything that is wrong with the database could directly impact their business operations, which we don't want, or at least the ICICI Bank does not want. So what they ideally do is, the banking application the teller is using does not directly update in the database itself. Instead, there is a JMS system here. All right. The JMS system is the one that stores a message generated by the front-end application. So you have app 1 here. App 1. That's a teller application. Teller app. So the teller app simply generates a message, puts it into the GMS system here. Let's say this message is M1. The message will have three fields: your account number, the amount that you have deposited, your name, whatever fields you have punched into the, or you have filled in the form. So the message is generated and the teller application will continue to work with the next thing. So the teller application job is done. So all that the teller application is doing is it generates a message, puts it into a JMS system. Then once the message is here, there is another application, app2. All right, here, application 2. This is another application, app2. This application will pick up the message from the JMS, executes an SQL query in the database. So here you have application 2 picking up messages from the JMS, executing an SQL query in the database. That's why you will see there is usually a delay in the update. When you go into the bank and deposit money, it's not always instant. They will say the normal SLA for a bank is it will take 2 hours for the money that you have deposited to be reflected into a account. But it's not, that max is 2 hours. So here you have an application, the JMS front end or the teller app generating a message, putting into a JMS system. Then a backend application, app2, picking up the message, putting it into the database. Even if the database is down, the impact on the branches is minimal. The branches will continue to generate the message. The message will be piled up here, that's it. But the operations will continue. Probably there is a delay, but there is no direct impact. So here app2 is the one that is updating the database. Now once the app2 updates the database, app2 generates your alert message. Now the alert message again has to be sent out as an alert. Alright, so before we go in there, let's see here. Teller application generated message 1, put into the JMS, app2 picked up. Now let's say there are lots of such messages. M1, M2, M3, M100, M1000 messages. Alright, thousands of messages piling up into the JMS. Obviously, when there are thousands of messages, you can't have a single application 2 instantly. Let's say application 2 is a Java application. Because it's a Java application, I assume it's deployed to Weblogic. One of the managed servers is hosting app 2. Obviously, the one managed server cannot handle all this load. Now to reduce or to balance the load, let's say we have put multiple instances of app 2. So we have created a domain with 4 or 5 servers. With 4 or 5 managed servers are all hosting the same application 2. Alright, all of them, what they are doing is going to the JMS system, picking up the message, going to the database, executing an SQL query with the details in the message. Now take a question here. Let's say managed server 1 has picked up message 1, MNG1. So when managed server 1 picked up message 1, it went to the database and then updated the details. Now if the same message is picked up by managed server 2 also, what will happen? Remember, all these managed servers are hosting the same application. Managed server 1, 2, 3, 4. MNG1 picked up the message M1, went to the database, filled it. MNG2 also, if it picks the same message M1, what will happen? I think the chart is not getting displayed here. I can't see the chart. That's why I can't see your answers. Oh. Ah, that's a credit. That's correct. You get double the money. No data integrity issue, Kishore. There is no data integrity issue. You got the money twice. Why is duplicate data? Can't you deposit 2 times the same amount? Application is expected to take the message, turn it into an SQL query, execute the SQL query. That's what the app 2 is expected to do. There is no duplicate data over there. Of course, that's a duplicate data from a bank's perspective, but the application is functioning pretty, according to what it was asked to do. The problem is the message was delivered or the message was processed by 2 different GMS or JVMs. That's the problem. Let me open this one. Alright, going back. Data is wrong from the bank side. What is wrong with the application perspective? What is that application did wrong? Technically, do you see something wrong anywhere? It's a business fault. It's a business fault arising out of a mistake in technology. But the technical application itself is functioning well. You don't see any errors in the application. Application 2 is expected to put the message into the database. It puts it. And we are happy to get that credit. Isn't it? Yeah, we are happy. Now here, as you guys are mentioning, the problem for the bank is if the message is processed by 2 instances here, they're going to be bankrupt. So in this scenario, I want message 1 to be processed only by 1 instance. Now all you guys mentioned the application 2 has to verify that one, that it's a duplicate data. It's not the application 2 that's worried about the data. Application 2 has a very simple functionality. Take the message, execute an SQL query. It's not expected to verify whether it's already done or not. Now the burden is put onto the JMS system. The burden is each message has to be delivered only to one recipient. If that is done, the moment message 1 is delivered to MNG1, the message 1 gets discarded from the system or JMS. So the message 1 is not delivered to anybody else. The burden is on the JMS system. So the JMS system has to guarantee each message, in this case, should be delivered only to one receiver. You have multiple receivers. MNG1, 2, 3, 4, there are lots of receivers. But per message, it's delivered only to one instance. If that's the case, my problem is solved. And that kind of implementation of JMS is called a point-to-point implementation. So here, between Teller app and app 2, you have a JMS system which requires a point-to-point communication. Point-to-point. It's usually called P2P. Now the JMS system guarantees in the point-to-point communication that each message is delivered only once. Now this kind of communication is implemented in JMS using what is called a queue. Alright. Now as opposed to a point-to-point or a queue messaging model, take let's say one step further from here. Here application 2 is executing an SQL query. Sorry guys, sorry about this. Application 2 is executing an SQL query. When application 2 executes an SQL query, your money gets updated into the database, and then application 2 generates what's called an alert message. The alert message that you receive on your SMS, which says you have deposited X amount, your total balance is Y. That's a kind of message you will receive. Now that message is generated by app 2. Now obviously the message, if you have observed, we usually get two types of messages. One is an SMS alert we get. We also get an email alert. Now the body of the message is same. It always says you have deposited XYZ amount. The total balance is ABC. So here what application 2 is doing is it is generating a message. Alright. That message, let's say M10, has three fields. Body of the message, let's say email ID of the current user, then mobile number. Let's say these are the three fields that the message has. Now this message in the entire system, we want this message to be used by two external systems. One is an SMS system. So we have application 3. Application 3, let me draw a diagram. Application 3 is an SMS application, app 3. Alright, we want the SMS application to pick up this message, send the body to the mobile number. Alright, the same way we want also another application, app 4, which is an email application. App 4 also, we want app 4 to pick up the same message, send the body to the email ID. So here this is completely different from this message M1 that we have. We want M1 to be picked up by only one receiver, whereas here M10 we want this message to be picked up by the multiple applications. This is another requirement. So here the JMS system, which is storing this message, has to deliver the message to multiple applications. So here I have a JMS requirement. This is again another JMS system. The first one is one different JMS. This one is another JMS system. This JMS system, the requirement is each message has to be delivered to multiple receivers. So this will go here. A same message will be delivered to this one also. And this is the second type of communication. This type of communication is called a publish-subscribe communication. Oops. Publish, subscribe communication. Now this type of communication is implemented by using what is called a topic. Usually topics are represented using squares or rectangles, and queues are represented by using a pipe-like structure like this. I don't know how to draw it, but Let's say this is a queue. A queue, it's like a pipe. So messages come in, messages go out. Now both these queue and topic receive the messages. But the difference between a queue and topic is in terms of how they send out the message. In terms of queue, each message will be delivered only to one receiver. In terms of a topic, each message can be delivered to multiple receivers. So queue guarantees that a message is delivered only to one receiver. A topic guarantees each message is delivered to any number of receivers. Both of them follow what is called FIFO mechanism. First message, first one out. First in, first out. Both of them. The first message but that arrived will be the first one to be delivered. So the message order is preserved. So here we have two kinds of JMS models. Model 1 is a point-to-point model which gets implemented using a queue. Model 2 is a publish-subscribe model which gets implemented by a topic. Depending on the requirement of the project, you may have queues, you may have topics, or you may have both. The application will decide where it wants to send the message, whether it wants to send a queue or whether it wants to send a topic. And there will be other applications which will subscribe to the JMS again. So each of these applications here are going to a JMS for a specific purpose. Give me one moment, guys. I'll be back in a moment. Okay, so I'm sorry about that. I have this very bad cold. Okay, so two types of JMS now I got. Point-to-point, publish, subscribe. One gets implemented using queue, other gets implemented using topic. Difference between them is queue delivers only to one receiver per message. Topic delivers the same message to multiple receivers. Depending on what your requirement is, you may have one, two, or both. Alright. Now here again, after this point, SMS application delivers an SMS to your mobile number. Email application delivers an email to your mobile number. Now both these message models, queue and topic, are P2P and publish subscribe. Both of them are asynchronous. So the difference between queue, this is the most important difference, guys. A lot of people don't understand this difference. Now what you will see in all the documents everywhere is queue has a single receiver, topic has multiple receivers. That's a common terminology used. It's a little confusing. It's not wrong. It's a little confusing. If you see here in the first one, app 1 and app 2, the JMS here is implementing a queue, but it is not having a single receiver. There are lots of receivers here. But the actual difference is a queue, each message will be received by a single receiver. Means MNG1, if it receives M1, that's it. M1 is not given to anybody else. So each message is only for one receiver. Whereas in a topic, each message can be delivered to multiple receivers. That's the distinction. It's not about the subscribers. Queue and topic both will have multiple subscribers. So app 2 here is a subscriber. SMS and email are the subscribers here. So here you will see a lot of keywords kind of thing being used. You will see sender and then receiver. Then you will see producer. You will see consumer. You will see publisher. You will see subscriber. Now these are the three pairs of keywords that you commonly use. Now you have to use these keywords in pairs. When you say sender, you say receiver. When you say producer, you say consumer. When you say publisher, you say subscriber. You cannot mix them, like you can't say sender and subscriber. That's wrong. Alright, so this is a commonly used terminology. Now what we are going to see is how these things are getting implemented in Weblogic. So whatever we have discussed so far is the fundamentals of JMS. They don't change anywhere. You are using Weblogic, WebSphere, AQ or MQ or TIBCO. These fundamentals remain same. There is a queue. The queue is always the one that sends delivers a message to only one subscriber. If there is a topic, the topic always can deliver the messages to multiple receivers, the same message. Fundamentals remain same. What we'll see is how Weblogic implements this entire infrastructure, or what are the various components of this green box that you are looking at. We're simply saying JMS is a green box. We did not really talk about what is inside it, and that's what we're going to talk now. What is inside this green box that facilitates an application to send a message, or the same way that facilitates an application to receive a message. Alright, let's move on. JMS 3. So let's going back. So we were talking about these things. This just if you are going through the PPT, this is a point-to-point communication. Alright, so there is only one application that can receive a message, each message, whereas a publish subscribe mechanism, the same message can be delivered to multiple receivers. This is a generic representation of a queue. There is a client, the message sent, queue will receive the message. There is a consumer basically consumes the message and acknowledges the message consumption. Then the message will be discarded out of your system. Then you have a topic. Client is there, publishes it. Multiple clients, client 2, client 3 will subscribe to it. When they subscribe, the topic will deliver the message whenever the message arrived, and client 2 will acknowledge it. So the topic here has multiple clients for the same message. Alright, who produces the messages? Basically producers. Any application can produce a message and put it into a queue or a topic. The same way, any application can consume a message from a queue or a topic. Now usually if you go in depth into the actual technicals, all these JMS related applications, means the ones that are producing the messages or consuming the messages, they're all EJB based programs. In EJBs also, there are lots of types of EJBs, means enterprise Java beans. There are lots of types of Java beans. You got session beans, message driven beans, then types of beans. Now what we are talking here is the message driven beans, MDBs. So you are actually looking at JMS programming, MDB. Not everybody knows about MDBs, even the Java programmers. So those people who know about JMS programming, they are familiar with the MDBs. This is a message driven bin, which means a bean that can produce a message, put it into the JMS system. Same way, a bean that can consume a message from a JMS system and do something with that message. So all the applications which are working with the JMS, the Java applications, are based on MDBs, message driven bin. That's more towards development, but that's more for information. Let's see how Weblogic implements the JMS system. Now here, this is a scenario we are looking at to simplify things. Now app 1 wants to send a message to a queue, Q1. Now app 2 is another application which wants to receive messages from Q1. So here, both app 1 and app 2 are trying to reach Q1. See this one. The purpose is different, but both of them want to go to Q1. Now for that reason, these queues and topics are usually called destinations. So queue and topic is usually called a JMS destination. This is a common terminology used. JMS destination is nothing but a queue or a topic. Why it's called a destination is every application wants to go to queue or every application wants to go to topic, but the defense is different. Once the purpose is different. So app 1 here is the producer, which is going to the destination queue. App 2 is a consumer, which is also going to the same destination, but for a consumption. Let's see what happens inside and how it establishes a connection and sends a message. This box is the application. Now application 1, which is this box, wants to send a message to a queue. It looks up the JNDI just like a database connectivity. When the application wants to get a database connectivity, it looks up the JNDI, gets a data source. The same way here, application wants to send a message to queue. It looks up the JNDI. It gets an object called connection factory. The connection factory is a JMS object bound to the JNDI. Now the connection factory object will be given to the application. Now the connection factory, what it does? It basically allows application to create a connection. It has all the parameters, variables like how long the connection will be valid, how many number of connections can be made from application 1 to queue, means using the same session information, how many connections can be made, means how many messages, let's say to simplify it, how many messages can be sent in each connection. So let's for the sake of simplicity, let's say this connection factory object tells this application everything about how to send a message or how long the messages or how long this your connection is valid, the timeouts of the messages, the sizes of the messages, everything will be told to the application. Once that information is with the application will go on and create a connection object. From there it creates a session object. From there it creates a message producer object. Now all these three boxes are part of the Java programming. We don't have to really know about these things as an administrator, but we don't want to leave it either. So the more information, the better. So inside the Java MDB application, a Java developer has actually written this code. What it does is look up the JNDI, get a connection factory. From the connection factory, create a connection object. From there, create a session object. Then create a message producer object. So the application is ready to send a message. Now once a message producer is created, the application looks up the JNDI again, tries to find a destination it's trying to reach. Let's say Q1 is the destination. Now the Q1 information is also on the JNDA. Q1 information in the sense how to reach Q1 or what are the details of Q1 on the JVM. These are all basically reference points. So Q1 is also looked up. So now you have a connection factory. The Q1 information is also there. Application already looked up the JNDI, got the connection factory, created connection session message producer. Then it looked up JNDI again, got the Q1 object. Now it's ready. It knows how to go there and where to go. Once it is done, the Q1 along with the Q1 object, application 1 connects to what is called a JMS server. JMS server is actually the container of this queue. Container means the owner. The queue itself cannot talk to an application. Queue is more like a storage. So it does not know how to talk to an application, means how to receive a message from an application, how to acknowledge the application about the receipt of the message. Queue itself does not know. It is done by the owner of the queue or the container of the queue. The container of the queue is the JMS server. So application 1 here is talking to the JMS server. It's telling JMS server, I want to put a message in the queue. Now that telling is called a subscription. So what is happening here is application 1 registers a subscription with the JMS server. And the type of subscription is as a producer. So application 1 goes to the JMS server and says, look mister, I want to produce a message for the destination Q1. Now that subscription will be noted by the JMS server. So when the message is given to the JMS server, it puts it into the queue, acknowledges it back to the application. Now the same way, if an application wants to receive a message, everything remains same except this thing. Instead of a message producer, it will be a message consumer. Everything else remains the same. Now the application, obviously, assume this is Q2, a queue. If the application is same, I'll change the application. Let's say it's application 2. Let's keep the queue same. So application 1, I have to change it here. Application 1 has sent a message to this destination. Application 2 wants to receive a message. It also follows the same pattern. But here, instead of creating a message producer, which was the sender did, now the message consumer is what gets created. So that's inside the Java program itself. Now once the message consumer is created, it again connects to the JMS server, registers a subscription as a consumer. So any message that is coming into the queue will be given to the consumer in FIFO order. So the JMS server is the one that is talking to an application. It is deciding what message arrived, when it arrived, and puts it into the queue, gives it to the application in the order they were received. Now the same thing is for a topic also. Instead of a queue object here, you have what is called a topic. So the application wants to reach a topic now. If the application wants to reach a topic, T1 object is bound to the JNDI. Everything else remains same. Application looks up the connection JNDI, gets a connection factory. It creates connection session producer. At this time it looks up for a topic. Once a topic is looked up, it goes with the information of the topic to the JMS server. For a topic also, the container is JMS server. So both the destinations are managed by the JMS server. Now the same thing is true for a receiver. If somebody wants to receive a message from the topic, the JMS server is the one that is going to handle it. Alright, so this is the actual infrastructure. So you have a connection factory, you have a JMS server, then there is a Jms destination. These are the three things that actually hold. Now we have a couple of other infrastructure inside this JMS. Let's see. Now this diagram that you are looking at is pretty much same as this one. App 1, creating a connection, creating a session, creating a message producer or a consumer. Let me see this one. Look up the connection factory, creates a connection, then creates a session here. Alright. After the session creation is done, after this one, if the application wants to send a message, it creates a producer. If an application wants to consume a message, it creates a consumer. Then after creating producer or a consumer, it goes to the Jms server. Alright, it sends a message or it receives a message. So this entire process, this part of the entire process is same. This part is same whether it's producer or a consumer. Only at the last stage, you will either create a message producer or a message consumer. This is all done inside a Java program. We don't have to really know anything about it. See this thing? This is a Java application inside the Java application. MDBs related stuff. But it's good to know. Let's move on. Now these are some things that are related to the file system. You are creating all this infrastructure, isn't it? So what you will see is a JMS module, which means everything that you have created so far. If you created a connection factory, if you have created a queue and a topic, you logically bundle these two things together or three things together and you call it a JMS module. And that JMS module is nothing but an XML file on your system. You can see all the information of the connection factory, queue and topic in this JMS module. This is a logical thing. So here if you say, we said connection factory is the one that provides a connection. T1 is an object bound to the JNDI. T and Q are the actual destinations. JMS server is a server. Now the CF, Q and topic, these resources are bundled into what is called a JMS module. This one. A JMS module is a logical group of the JMS resources. The module will not have the server information. The JMS server is outside the JMS module. Remember that one. So what we have here is connection factories, queues and topics usually go into a JMS module. Now the next question is, now we will talk about JMS module. We'll see how this XML file looks like later. But let's see, if the JVM itself has crashed, what happens to the messages stored in the queue and topic? Anybody, any idea? We were talking all this fancy stuff. So application 1 wants to send a message. So let's say all the messages are received in here. Then you went on and you did a kill-3. Sorry, kill-9. So when you did a kill-9 on the JVM managed server 1, this is managed server. So what will happen to the messages in the queue? Once the JVM comes back, the messages will be delivered by, where are the messages stored? Are the messages getting stored anywhere? You kill the JVM. We all agree that the messages are all in the JVM, right? Yeah, where is that memory? In the queues and topics, and queues and topics are in the JVM. The entire JVM is your ps-ef grep Java, which you kill. See, this entire thing is happening in the RAM. Yeah, JVM controlled memory, which you kill. Kill-9. So you did a kill-9 on a JVM which is holding queues and topics, which are holding messages. If you kill that process, obviously there is no more process. So what will happen to the messages? The messages will be lost. That's correct. In this scenario, the messages will be lost. This entire thing is happening in MNG1, guys. That's something that we have to look from a very far range. That's a bird's eye view. How to understand that one? That this entire thing is happening in the PS-EF grub Java thing. You can simply do a kill-9 on that grub Java and everything, boom, gone. Obviously, that's not something that we want. Because if the JVM crashes, we don't want to lose the messages. Especially something like the one that we just now seen. The banking application. This is not something that we want to lose. The messages are critical. It's customers' money. I did not store it anywhere. Alright, anyway. So the messages will be lost if the JVM crashes. Obviously, we don't want the messages to be lost. As you guys said, we want to be able to recover the messages from some location if once the managed server comes back up. And the only way you can recover messages is by storing them permanently. And what's a permanent storage? I think this is a question a lot of people will get confused. What is a permanent storage, guys? A hard disk. That's correct. A hard disk. A hard disk is a permanent storage. It can be a file or it can be a DB, a database. So what we want is, we want the messages that are coming into this topic or queue to be stored to a file or a database. Both are permanent storages. Why we want to store it? We should be able to retrieve those messages in the event of this JVM crash. Now that kind of storage is called a persistent store. Weblogic provides both types of persistent stores. It can have a file store or a DB store. Now both the file store or a DB store are tied up with the JMS server. It's the JMS server that manages the stores. Means it will read the messages from the store, it will write the message to the store. So here we have a slight change in the flow now. The moment we put a store, we can decide which store we want. Then let's say you have decided on putting a store. Now after the message is received by the JMS server, the message will be first put into the store, then it will be put into the queue or topic. After it's put into store and queue and topic, then the JMS server will acknowledge the application. So it's not like the message will be put into the queue first and then into the store later. It's the store that gets priority. Means we want to store the message as fast as possible. I know anything can go wrong at any point of time, so we don't want to lose the message. So application gives the message to the JMS server. The JMS server immediately puts it into the database or the file store. Then it goes into the topic or queue, puts it there depending on the subscription of this application. After it puts it into the queue or a topic, the JMS server is going to acknowledge this application. It says, okay, we have received your message, we put it into the queue. If somebody asks for the messages, we will deliver them. So now you have a permanent storage, which is called a persistence store. Now, is persistence store good or bad? You should have persistence store or you should not. What are good things about it? What are bad things about it? You need to have. Why? Bad performance. That's correct. You answered both. It's good and bad. Persistent store is required if you want to permanently store the messages. Means if the messages are critical, you definitely want them to be stored somewhere because you cannot depend on the JVM itself. but having a store itself is bad. The reason is, we know that every time you touch hard disk, your performance is going to degrade. Hard disk, whatever type of hard disk, you take HDDs, SSDs, they are basically slow compared to RAM. That's what you are comparing, guys. Slow in a sense compared to something else. So here, when you have a persistent store, JMS server has to write the messages to the hard disk. Whether it's a file or database, it is irrelevant, but it still has to write it to the database, or to the hard disk. So if you have too many messages to the queue or topic, you have too many reads and writes. There is a lot of I/O activity. Any I/O activity overall reduces the JVM's performance, system's performance. So a persistent store is good for in a sense of reliability. It's bad in a sense of performance. So we all know reliability comes at a cost. So that's the cost is performance. The system is going to have a degraded performance. Now, for that reason, not every JMS implementation is going to have a persistent store. So sometimes you may choose not to have a persistent store. Means you don't want to store the messages. That's okay. Even if you lost the messages, it's okay. They're not that critical. Let's say like alert messages. Some banks may choose not to permanently store the alert messages. They're okay to lose certain messages. They'll say, okay, if our customer did not receive a message, they will not be worried. Some banks, I'm not saying all the banks. So if they decide that these messages need not be stored, then probably there is no DB stored. But if the messages are critical, they need to be stored, they will be. A persistent store gets into the picture and you have slightly reduction in the performance. Now this is an entire infrastructure of GMS. The most important thing is a connection factory, then the JMS server, then the QR topic, and optionally you may have a DB store, and the connection factory and the queues and topics are logically put into a JMS module. This JMS module concept is introduced in Weblogic 9.2. Earlier there was no JMS module. This is exclusively introduced to make it easy for the administrators. JMS module is nothing but a simple XML file that stores the information of connection factories, queues, and topics. Especially, let's say you have a domain with hundreds of queues. Now you want somewhere else the same queues to be created in another domain. So obviously you don't want to manually recreate all these queues, or even programmatically. It's difficult. So what a JMS module does is it gives you an XML file of all those 100 queues and connection factories. You can take the XML file to a different domain, just refer that XML file in the config.xml and restart your servers, everything will be picked up. So it's easy administration. Now when you're creating these resources, this is a little confusing. Alright, it is not as easy as it looks. So what you do is you create it in a very logical way. Now what you're looking at is a basic JMS. We did not go into advanced JMS yet. So in the basic JMS, you follow this order of creation of JMS related resources. You first create a persistent store. When you created a persistent store, it can be file or Jdbc. You will target it to a JVM. But it's not the JVM which is handling the persistent store. Inside this JVM, there is a JMS server. That JMS server is handling the persistent store. Now create the JMS server. Create a JMS server. Target it to the same JVM. We're talking only one JVM at this point. We're not talking about multiple JVMs. Only one JVM. Let's say you have only one JVM, you're setting up entire JMS on it. So you create a persistent store, put it onto the JVM. You create a JMS server, target it to the JVM. You create an empty JMS module, target it to the JVM, then fill the module, the last step, with the required resources. It can be queue, topic, connection, factory. So these are the 4 simple steps that you will follow. Now remember guys, this especially when you are doing it for the first time, follow these steps. You will become an expert at a later point of time once you understood the fundamentals. So you do it in the same order. You don't change the order. Usually because if you change the order, the error messages are really messy. You won't understand what the error is. It's really difficult to go back and redo everything. So create a persistent store first. Then create a JMS server for that persistent store. Create a module that can hold all the resources. Then fill the module with all the resources. That's what we're doing. See, this is a diagrammatical way of doing it. The Pentagon is a managed server. The first thing you're doing is creating a persistent store. Let's say it's a DB based persistent store or a file based. Whatever it is, you create it and you target it. Then you create a JMS server, target it to the persistent store. Then you create a JMS module. Alright. Then you create a queue, connection, factory, or everything. Now all this information of queue and JMS module is stored in a XML file. The location of the XML file is in the config directory again. In the config directory, you have an XML file with the module name. That is in the JMS directory. Alright. So let's go ahead. Now this is advanced JMS. We'll come back here later. Let's go ahead and quickly create one just to give you a first-hand view of the JMS thing. Oracle middleware user project, domains, encode daemon. I'm going to start the admin server, log into the console, and then create all these things. I'm going to pin admin.log. Right, it's in running mode. Let's start one of the managed servers also. Let it come up. Let's log into the console in the meantime. Let's try to create a Jms Resources, assuming we have only one JVM. We are trying to do a very simple thing at this point. When you have multiple JVMs, things get complicated. That's all advanced JMS. We will do that later. So let's get into WLS admin, WLS admin 1, 2, 3. Alright, so your Jms Resource Creation, we're going to follow this order. Alright, these 4 steps is what we're doing. Let's do it. I think there's a problem. Okay, the startup class. So we'll go into services, messaging services. These are all messaging services. Alright, the first thing you're trying to do is create a persistent store. So click on the persistence. This is outside messaging. Alright, you don't have to go into messaging. Create a persistent store. Now you got 2 types of persistent stores. It can be a file store or it can be a Jdbc. If you ask for a file store, it will ask you what's the name of the file, the location of the file. If you choose a Jdbc store, it will ask you what is the data source that you want to use, alright, to create the Jdbc store. Now here, for a Jdbc data source, Currently there is nothing it's saying because XCA type of drivers will not support a persistent store. That's one thing that we have to keep in mind. And our domain does not have any non-XA. These are all XA type. XA type is not supported. Means the global transaction stuff is not supported. Now here you can specify a non-XA type data source, alright, and target it to a JVM, and then give a prefix name to the tables, because it is going to create certain tables in the database to store these messages. Now as opposed to it, you can create a persistent store which is file based. Create a file based. The same thing, it's going to ask you for the name of file store. Let's say we create a file store, target it let's say to mng1. Where do you want to create that? That's where it will go. And let's say if you don't give anything, it will be created into the data directory. It failed. Okay, ds1 ds2 failed. That's why they did not come up. Data source failed. Anyway, we'll see that. So here, if you target it to mng1, you can give a path directory name where the file store. This file store gets created with the fs1.dat file. Now normally if you don't give any location, it usually goes into this area: servers, domain home, servers. Let's say you have targeted to mng1, shift insert. Alright, it goes into data store default. Alright, this is a default store. Along with this, fs1.dat also gets created once you put messages into it. Alright, this is a default location. Means if you don't specify anything in here, a directory gets created here, and it's usually the practice. You don't really specify a location. So let's say I'm targeting to mng1, this fs1, create it. So I've created a file store first and targeted it to the JVM. I did just according to this one. Create a persistent store and target to the JVM. That's what I did. Now I'm going to create a JMS server, target it to the same JVM, because the same JMS server is going to read and write from the persistent store. Alright, fs1 is ready now. Now let's go ahead and create a JMS server. Click on the JMS servers, create a new JMS server, give a name to it. Let's say JMS server 1. Right, select a persistent store that just now you have created. If you don't select anything, it means this JMS server is not associated with any persistent store, so the messages will not be stored permanently to the hard disk. They will be only in the QR topic, and if that JVM itself crashes, you will lose the messages. So this is a file store. Let's say target it. I say target it to the same JVM. Finish it. Alright, so you have created a JMS server, and this JMS server is associated with this persistent store. Now create an empty module and fill the module. Third and fourth steps. JMS module. Go into JMS modules here. Third step, JMS module. Create a new one. Call it a name. Let's say JMS mod 1. We know that JMS modules are XML files, so you have to give a file name. Now obviously when there is a file, you should give a location to store that file. Now usually you don't give both these details. If you don't give these details, it gets stored into this location, this one. So let's go to this location, domain home config JMS. So under your domain home, go to config JMS directory. This is your domain home. Config, the location where you have config.xml. This is config.xml, and the same location you have JMS directory. Go into JMS directory. Here you don't have any XML file. Once we create the module, you will see the XML file again. We'll come back to this location again. So go back. Here, I'm not giving anything here, which means it gets created in the default location, which is here. To move on to next, I'm targeting the JMS module now. Now, if you remember, for file store, you got a drop down. You have selected one server. For JMS server also, you got a drop down. You have selected one server. Means file stores and JMS servers can be targeted to only one server, whereas JMS module can be targeted to any number of servers. This is the most important point you have to remember, because we're going to define our entire advanced JMS on this fundamental. This is the starting point of the advanced JMS. A persistent store can be targeted to only one JVM. A JMS server can be targeted to only one JVM, but a JMS module can be targeted to multiple JVMs. That's the point. So you got a drop down for persistent store, you got a drop down for JMS server, but to the JMS module, which is the third step here, you are getting a checkbox. You can check multiple servers. So this is the beginning of the advanced JMS. So here, let's say we select the same server, because we are doing it only for one server. It's a simple JMS system. We will go into advanced later. So select it, move on to next. Add resources to this module. That is the fourth step. Fill the JMS module. You can finish the fourth step also here by selecting this, or if you don't select it, you will finish it here itself without adding anything. So you have created an empty JMS module. Now that's the fourth step, is to fill this JMS module with connection factories, queues, and topics. Let's do. So go into the module. This is a summary of resources of this module. There's nothing in this moment. So create a new resource. Connection factories, queues, topics. These are all the resources. There are lots of resources. We will talk about some of these things. So you have connection factory, queue, topic, distributed queue. It's a DQ. Distributed topic. It's a DT. Foreign server, quota, destination sort key, JMS template, SAF imported destination, remote SAF context, SAF error handling. You don't have to know about all these things. They are not really used everywhere. The first 5 are important. By end of this JMS sessions, we will know about all these 5. Alright. So for now, we already know about these 3. We will know about these 2 in advanced JMS. So let's try to create a connection factory first. Select it, move on to next. Give a name to the connection factory. CF1, let's say. Now the connection factory is bound to the JNDI. So we know that one. Alright. So give a name to this one. It's a GMS type of object, connection factory. Alright. We will talk about these things later. Alright. For now, go ahead with only these 2. You can actually keep all these parameters as they are. So connection factory, GMS, the JNDA name of that one. Next. The connection factory automatically acquired the targets of its module. Let's go back to this one. We know that we have created an empty module, and we already know the JMS module itself is targeted to a bigger box. So here, if you look at it, this is what I am trying to do here. You have a bigger box, which is called a JMS module. In this module, you are creating a connection factory. We know the JMS module is already targeted to a JVM. So let's say this is a JVM. You already know this is targeted here. So once the bigger module is targeted, anything that you put inside it, like connection factory, will automatically acquire the targets, like MNG1. So if the JMS module is targeted to MNG1, the connection factory which is inside this green box will automatically acquire this target. This is another point for advanced JMS. That's what happened here in this diagram that you're looking at. So the connection factory acquired encode MNG1 as a target because connection factory is inside the JMS module which is already targeted to MNG1. So go ahead with the default selection, finish it. So the connection factory is created. Now the targets of the connection factory are same as the JMS module that's holding it. It's called default targeting. Move on to next. Sub deployment, we'll talk about it later. Queue. Give a name to the queue. JNDI name. Let's say this is JMS type of object. Name of object. Template. Queues can be created. Default queues are custom queues. Means are default properties versus custom properties. That's what it means actually. Default properties are like the size of the queue, for example, or the message size in the queue. Means each message, how much is the size, then the expiration time for all those messages, means how long they're going to stay in the queue. These properties are set up by default by Weblogic when you're creating a queue. Now let's say you don't want to use those properties set by Weblogic. Instead, you want your own custom properties for the queue. Then you can set up a template. That template can be assigned to a queue. So a template will allow a queue to be customized. Right? If you have a template, you can actually create it as a resource and attach that template here. Most of the times you don't have anything related to template. So let's go ahead with queue and the JNDI name of it. Go on to next. Now this is the most important thing. When you selected connection factory, the connection factory was inside the module, and the connection factory acquired the targets of module automatically. But here the queue is also inside the JMS module, but the queue did not acquire encode MNG1 as a default target. Instead, it's asking you for something called sub deployments and targets. Did all of you realize that? I just want you guys to take a moment here, understand the difference between what happened with a connection factory and what happened with a queue, because this is the basis for the advanced JMS. A queue did not acquire all the targets of the parent module, JMS module. Obviously, in this case, the parent has only one target, encode MNG1, but even that one target, the queue did not acquire. Whereas a connection factory, it acquired the target, encode MNG1. The queue did not. All of you understood this point? Just realize this point, that's it. Why this did not acquire, we will talk later. Just have to take a moment, understand this point. Then we'll move forward. I'm not expecting any questions here. So connection factory acquired the targets, but queue did not. That's what you have to understand. Now once you have that point, let's move on. In this case, we can finish it because the targets, possibility of targets is only one here. So even if you don't select anything, that still encode MNG1 will be the target. We'll have these problems when you have module having multiple targets, then you will have problem with the queue. Which of the targets are all the targets the queue is going to acquire? We will see all those things in advanced JMS. So here, this queue is going to acquire the only target possible, encode MNG1. So queue is created. The same way topic can be created. T1, JMS, T1. If you want to create a custom topic, you can set up the template the same way. Queue and topic both have the same properties. They did not acquire the targets. See this one here. There is no default targeting, whereas for a connection factory, default targeting means whatever are the targets of the parent, the connection factory also will acquire. So like this, you have created 3 resources. DQs and DTs we create later. So once these resources are created, your job as an administrator is done. You can actually deploy an application, an MDB based application. The MDB based application will register a subscription and other stuff. Now if you want to monitor the queues, you can go into connect queue. You can actually get into monitoring. You will see all the messages. How many current messages are there? How many are pending? How many were total? How many consumers are currently available? What's the max number of consumers? How many total consumers are there? What is the message? How you can customize this table again. Alright. So you can set up all this. Pretty much all the important parameters are already there. So you can monitor the queue also here. Now usually what is the thing that you monitor is the message pending. You don't want too many messages piling up in the queue. If too many messages pile up in the queue, the JVMs will slow down. The JVM will slow down, or you know that there is a problem. Q and T will target once managed server is, what is it? Once the managed server is up? No, that has nothing to do with managed servers up. The Q and topic acquired the target because there is only one possibility, but it's not showing up over there. We'll talk about the reason in advanced JMS, why it is not showing up the encode MNG1 there. But it actually has no other choice. Encode MNG1 is the only target. And these are the monitoring tabs usually you will see at the pending messages. So you will have a WL08A script kind of thing, or you can always come to console and we usually look at the pending messages. You make sure the pending messages are not too many. This should be a constant incoming and outgoing. Means if you have 100 messages, probably it go up to 100, 150, 200, then it should come down to 100. Means the messages should be consumed. It cannot keep on increasing. But it does not mean it's zero. The pending messages will be there on a live system, but they keep they don't increase. On a peak timings, you will see an increase in the pending messages as the evening comes in. So all the pending messages get cleared by evening. That's how it the typical behavior is. All right, so that's your basic JMS, guys. So we've just understood the general structure of JMS. What we did not or not yet touched is the advanced part. That's going to be a little tricky and interesting. All right. So what I want you to do today is just go through the video. Definitely go through the video. Understand the fundamentals, because otherwise your advanced JMS is going to be really messy. So you're going to come across a lot of concepts that you will get yourself confused if your fundamentals are not strong. So I really want all you guys to go through the video today and execute the steps. Just create those Q's topics, the 4 steps. I really want you guys to do that one quickly, just 1 hour, half an hour after we finish the session. Also you can connect to cloud and do that. All right, then I'm going to get into advanced JMS. All right, so we'll stop it here for today. I'll continue tomorrow with advanced JMS. That's going to be interesting. Can we configure JMS by using? Yeah, you can do anything by WL08A. Okay, guys, any questions by the way in JMS? Okay, if you don't have any questions, you can disconnect and Happy Christmas. Enjoy. I'll see you tomorrow. You guys are going to join tomorrow, right? Especially for those in US and UK. I think is Chaudhary on the call? Chaudhary did not join today. Srinivas, for you. You'll be joining, right, tomorrow? Because other guys.
Yes.
And everybody in India, you guys will be joining. Yeah. I think nobody has issues, so we'll continue the session. Cool. So I'll see you tomorrow and we'll talk about advanced JMS. Thanks, guys.